Mr. Wilson here. We're going to look at some electrolysis today. First, I'm going to take you through the electrolysis setup, and then we'll see some of the things we produce in 3 different electrolysis experiments. Just do my jacket up so I'm nice and safe. Safety specs as a precaution. So what I've got here, I've got a power supply. Here I've got my positive terminal. So that positive terminal is coming into this end. Positive will be the anode. So that is clipped onto this graphite electrode. That is the anode, it's the positive terminal, it's where oxidation will happen. Here's my negative terminal. This is coming into this electrode. It's negative, so it must be the cathode. The cathode is where reduction will happen. The electrolyte that I'm using is, I'll just reach across, copper chloride. So at the electrodes, I'm going to produce oxidizing at the anode. I'm going to oxidize chloride anions and produce chlorine gas. Reduction at the cathode, I'm going to reduce copper cations and make copper metal. Here we go, let's turn it on. And I hope you can see, in fact I'm going to bring you in close so you can see that I'm producing chlorine gas through electrolysis. The electrons are travelling to the electrode. Oh, that's a fantastic view. I hope you can also see, I'm actually going to lift the electrodes up. And we should be able to see, there, look at that copper metal. Fantastic. Got copper metal depositing on the cathode and chlorine gas being produced at the anode. So the chloride anions are losing electrons, being oxidized. The electrons move through the circuit, through the power supply. They go back to the cathode where they're added to the copper cations and reduce the copper cations to make copper metal. Well, that's the first electrolysis experiment. I've got another one that's actually the same, which I'm going to wheel you around to now. Here is our second experiment. This is exactly the same, but I've got a slightly different setup. So when I turn this one on, this time I've got, where are we? Here's my positive terminal coming round to the anode. At the anode I'm oxidising chlorine gas, and because I've got the upturned test tubes, I'm actually collecting the gas this time. So again, I'm going to move the camera. Hope you can see the bubbles collecting in that tube. That's all chlorine gas I'm collecting. Now I can prove to you it's chlorine gas. Let's set it back up looking at the first experiment again. I've got some litmus paper. Now, if I get litmus paper damp and expose it to chlorine gas, it gets bleached by the chlorine gas, which means it takes the colour out of the litmus paper. So there's some damp litmus paper. We can see it's blue. I'm just going to hang it in by the anode where I've got my oxidation of chlorine happening. I can smell the chlorine gas, it's very strong. Look at that. It's definitely got bleached by the chlorine gas. So I'm going to turn it off before I poison myself with the chlorine. And I'll turn this one off too. Right, the final electrolysis that we're going to look at over here, this is what's called a Hoffman voltammeter. And it's how we do an electrolysis experiment where we want to collect some gas. So you might see I'm collecting gas in the tubes here. I'll come back round on camera again. Let's fire up the power supply. So let's find my positive terminal is red. It's going to the anode, so I'm oxidizing here. My negative terminal is black. It's coming around to the cathode. I'm reducing at the cathode. In this case, I've got a solution of lithium sulfate. Now that means that I'm not going to reduce the lithium. Instead, I'm going to reduce hydrogen ions in the water because hydrogen is less reactive than lithium. So I'm going to produce through oxidation, sorry, not through oxidation, through reduction. Through reduction, I'm going to reduce my hydrogen cations and produce hydrogen gas. So that's what I've got here. I'm producing some hydrogen gas. I've got sulfate, lithium sulfate. So I've got sulfate anions in the solution. And we know that in electrolysis, we produce a halide if it's present, but otherwise we're going to produce oxygen gas in aqueous electrolysis. So here at my cathode, at my anode, I'm oxidizing hydroxide ions from a solution to produce oxygen gas. So I've got a lithium sulfate solution, but I'm producing hydrogen gas at the cathode and oxygen gas at the anode. There's one really cool thing that I'm going to show you on here as well. So this is fantastic. What I've got, here's my tube that's collecting hydrogen gas at the cathode. We can see I've collected about, just let that focus. Come on, focus in. I've got about 22 millilitres of hydrogen gas collected. I'm just going to put my hand there, see if that helps it focus. There we go. About 22 millilitres of hydrogen gas collected. Let's come and look down at my anode again, where I'm producing my oxygen gas. The bubbles aren't coming up quite so fast on this one. Let's see how much oxygen gas I've got. I've only got about 11 millilitres of oxygen gas. So I've got half as much oxygen gas being produced as I've got hydrogen gas being produced. That's because the formula for water is H2O. So I've got 2 atoms of hydrogen and 1 of oxygen. So when I'm making H2 gas and O2 gas, I get twice as much H2 as I get O2. So there we go, there's my 3 electrolysis experiments. We saw the chlorine and the copper being produced in the copper chloride electrolysis here and here. And I saw my Hoffman voltameter is electrolyzing water, producing hydrogen gas and oxygen gas. Very cool.